Good morning, all of you. I welcome all of you for this show, Minerals. I am Professor R. SINGARAVEL, Professor from the Department of Soil Science and Agriculture Chemistry, ANNAMALAI University. Minerals, we are focusing on the soil forming minerals. A mineral is defined as naturally occurring inorganic substance having definite chemical composition and distinct physical characters. So, from the definition you can see it is an inorganic substance. Each and every mineral is made up of definite chemical composition and each one is having various physical properties which are distinct to each. Say for example, hematite Fe2O3. So, the chemical composition is definite in the sense Fe2 oxygen 3. Silica example of mineral SiO2, silica SiO2. So, the chemical composition is definite. It usually consists of two or more elements in chemical combination and in certain definite proportion. The other way, just as I explained, Fe2O3 they contain different element, iron and oxygen, silica SiO2, silica and oxygen, two or more elements, calcium carbonate, calcium, carbon, oxygen. So, each and every element have one or more elements in chemical composition and in definite proportion. The proportion is definite. There are minerals we can classify as primary mineral, secondary mineral, auxiliary minerals, etc. First we will see about primary mineral. So, primary in the sense first. So, these are the minerals which were first formed when the molten magma is solidified, or in other words it is the original component of a rock. So, those mineral which forms the original component of a rock is known as primary mineral. Example for primary mineral is quartz, feldspar, hornblende, mica, etc. Secondary mineral is subsequently formed. A mineral which has been found, deposited or introduced as a result of subsequent changes in the rock is called as the secondary minerals. Example for secondary minerals are limonite, gypsite, etc. We can also include clay minerals like kaolinite, montmorillonite, vermiculite. Then the next one, essential mineral. Essential, these are the chief constituents of the rock and the characteristic of the rock is mainly depend on the presence of this mineral. So, those mineral which forms the chief constituents of a rock and which are regarded as characteristic component of a rock is known as essential mineral. Example is feldspar, pyroxene, mica. Next one is accessory mineral. They occur only in small quantities and their presence or absence have no significance on the characteristics of the rock. So, those minerals were called as the accessory minerals. So, when you see accessory minerals which occur only in small quantities and the presence or absence of these have no consequence as far as characteristics of the rock concerned is called as the accessory mineral. Example for accessory minerals are tourmaline, hematite, magnetite. So, each mineral, as I said earlier, they have distinct physical properties, they have distinct chemical composition. So, by various physical properties we can identify the minerals. The example for physical properties are color, streak, luster, opacity, hardness, cleavage, fracture, etc. So, we will see what are all the various physical properties of the minerals and one by one how they are explained. Streak, the first physical property by which we can identify the mineral. Streak refers to the color which is produced when the finely divided particle of the mineral is abrased on the glazed porcelain tile. You take a glazed porcelain tile and then you make a scratch on the porcelain tile using the fine powder of the mineral. So, what is the color it appears is called as the streak of that mineral, by which you can identify a particular mineral. Second one is the cleavage. The second physical property, cleavage. It is a tendency of the mineral to break or split along smooth flat surfaces that are related to zones of weakness in the crystal structure. So, the minerals will break upon on the line of weakness, and when it breaks it gives smooth, or it breaks on the smooth surfaces, line of weaknesses. These mineral break along one direction, two direction, three direction, and at various direction, not at right angles. So, accordingly the minerals were called as cleavages, rather cleavages are called as cleavage in one direction, example is mica; cleavage in two direction, example is feldspar; cleavage in three direction at right angles, which is called as a cubic cleavage, example is halite, NaCl, sodium chloride. Then cleavage the direction at three direction but not at the right angles, it is called as the rhombic cleavage, example is calcite, calcium carbonate. Then the third property is color. Coloration in mineral is said to be inherent when it is fairly constant for all the samples of a given mineral. So, color, by color also we can identify a mineral. Next property is hardness, very important property, hardness. Hardness in mineral is defined as the resistance offered to being scratched or abraded. When you cause external, when you try to cause damages, or when you try to make a scratch on the mineral, how far it resists for such a action is called as the hardness. So, Mohs, he has devised a scale called as Mohs scale according to the increasing order of hardness. These 10 minerals, for convenience sake, they have taken and then given a scale. So, this scale is called as the Mohs scale of hardness, starting from talc, then gypsum, then calcite, then fluorite, apatite, orthoclase, quartz, topaz, corundum and diamond. So, this is the Mohs scale of hardness. The softest mineral is talc. The talcum powder what we are facing is it is made up from clay. So, talc is the softest mineral having Mohs scale of 1, whereas diamond is the hardness of 10, the highest resistance it will offer for when you make a scratch on the mineral. So, softest mineral is talc, the hardest mineral is diamond, it is called as the Mohs scale of hardness. Then luster, another property by which you can identify. Luster refers to the way a mineral surface reflects light. It is one of the key properties used to identify the minerals. The appearance of reflected light can vary depending on the mineral surface and composition. So, it is the light reflecting property by which you can identify a mineral. Example is metallic luster seen in pyrite or galena, where the surface shines like a polished metal. So, it is a property called luster by which you can identify the mineral. Then structure. Structure refers to typical cleavage, typical shape or forms of crystal. It refers to typical shape or forms of crystal, crystal fragments or mineral aggregates. Various structures are platy, micaceous, granular and blocky structure. So, there are different structures, platy structure, platy, then micaceous, granular and blocky structure. So, those were the various physical properties we employ to identify the minerals. Now we will see the composition and properties of soil minerals, very important soil forming minerals. The most abundant mineral present in igneous rock, which represent the original rock in the earth crust. So, some mineral, primary minerals, we call it as primary mineral, they form the original component of the rock, and they are called as the primary mineral, or they are present in the igneous rock, the first formed rock on the earth crust. The various mineral on this category includes feldspar, they constitute about 60%, pyroxene and amphiboles, they constitute about 18%, quartz 12%, mica 4%, and other minerals 6%. We will see one by one the important major category of soil forming minerals. We give emphasis on soil forming minerals. The first one is quartz. Quartz, it is SiO2, silica, otherwise called as silica. It occurs in all soils. In all the soil, silica is the mineral which appears. In all soil, silica occurs in the form of quartz, SiO2, and in some free silica occur as opal, agate, flint, and chet. Quartz is an important constituent of all the three classes of rocks. So, it is present in igneous rock, metamorphic rock, and sedimentary rock and metamorphic rock. So, the soil is presumed to be formed from any one of these rocks. So, invariably all the soil contain quartz as one of the mineral, and is present in almost all the soil. It is present in almost all the soil, of which sand and coarse silt fraction contain the largest amount. Sand and coarse silt contain highest amount of the silica or quartz. The second important mineral is feldspar. Feldspars are anhydrous aluminosilicates of potassium, sodium, and calcium. It is divided into two groups, orthoclase feldspar and plagioclase feldspar. Orthoclase feldspar are otherwise called as potash feldspar. It includes orthoclase and microcline. So, these feldspar are the source of soil potassium, the major mineral, very important mineral, potash, KAlSi3O8, KAlSi3O8. So, potash feldspar, it is also called as the orthoclase feldspar, important source of soil potassium. The potash feldspar occur usually in silt and sand fraction and are sources of soil potassium, KAlSi3O8. Then plagioclase feldspar, it is also called as soda feldspar. Example is albite, NaAlSi3O8, sodium. When it contains sodium, it is called as albite. When it contains calcium, it is called as anorthite. It is called as anorthite. Calcium feldspar is called as the anorthite, soda feldspar. So, feldspar are the important mineral which are the richest source of potassium, calcium, sodium, etc. in soil. Pyroxene and amphiboles, commonly known as ferromagnesian minerals or ferromagnesian silicate minerals, and they are predominant in igneous rocks. So, all these silica, then feldspar, then pyroxene, amphibole are present in igneous rocks, or they are the primary minerals. All these three were primary minerals. The crystal structure consists of silica tetrahedra with the substitution of trace elements and other nutrients, calcium, magnesium, iron, etc. Pyroxene and amphiboles are again the important group of minerals which supplies many nutrients to the soil. So, first one is pyroxene. Pyroxene, the important mineral belonging to this group are enstatite, MgSiO3. Example is hyperthene. So, it supplies magnesium, iron. Then augite, calcium, magnesium, iron, silica, alumina, all these are present, augite. Then amphibole, example is hornblende, sodium, calcium, magnesium iron. Then tremolite Ca2Mg5Si8O22OH twice. So this mineral is able to supply calcium, magnesium, silica, etc. Actinolite, calcium iron silicate, calcium iron silicate. So pyroxene and amphibole constitute the important group of primary mineral which supplies many of the micronutrient ions such as iron, then magnesium, calcium, etc. to the soil. Then tourmaline is example for boron containing mineral, one of the important micronutrient boron, which is very much important for the quality of the crops, which depends upon the quality of the crops in mostly fruits and vegetables. So when this nutrient is deficient, the fruits and vegetable produced will be not rich, and there will be malformation, cracking of walls and other properties. So tourmaline is an example for boron containing mineral. So this mineral is of importance to soil science because of the content of boron, an essential micronutrient for plant growth, tourmaline. Then calcite and dolomite. So calcite, already you can see calcium carbonate derived from limestone, marl, chalk, marbles, etc. Then dolomite CaCO3, MgCO3. So these are the major supplier of calcium and magnesium nutrients. Gypsum and pyrite. So they are sulfur bearing mineral, CaSO4, gypsum. Pyrite, FeS2, iron sulfide. So iron sulfide, it is present in slate, limestone, sedimentary rock deposits. Then oxide minerals, they are the group of mineral: allophane, gypsite, hematite, and then rutile. These are example for oxide minerals. Allophane is an example for amorphous mineral. Most of the minerals are crystalline. It is an example for amorphous mineral. And another important property of this allophane is a volcanic origin. It is of volcanic origin. So amorphous aluminosilicate mineral containing aluminum, silica, and varying amounts of other constituents including iron. So allophane consists of silica, alumina, iron. Allophane occurs as a product of weathering of volcanic ash. Here you can see it is a product of weathering of volcanic ash, strongly bound with humus, giving dark color soil called soil group, endosols. Soil derived from volcanic ash is grouped under the category endosols. So it is an example for allophane is an example for amorphous mineral derived from volcanic ash. The soil developed from volcanic ash is rich in allophane, and they are grouped as endosols. Gypsite, aluminum oxide, Al2O3. The previous one is iron oxide, aluminum oxide, iron oxide, allophane. Gypsite is aluminum oxide, Al2O3, AlOH thrice or Al2O3 is called as the gypsite. It is the most abundant free hydroxide of alumina in the soil, occurring in tropical and subtropical regions which have undergone intensive leaching of silica. When silica is leached, then the alumina will be enriched in the soil, then becomes aluminum hydroxide, gypsite. Then the next one is hematite and geotite. Hematite, I often used to give this example. Hematite, easy to remember. Iron oxide, Fe2O3, iron oxide. Hematite is iron oxide. We are now seeing the oxides of minerals. So gypsite, allophane, then hematite, geotite. Hematite is Fe2O3. It is the two most important oxide minerals are hematite and geotite. Hematite is having the formula Fe2O3. It is crystalline in nature, occurs in sand and silt fraction of soil, imparting purple color when it is oxidized. Hemoglobin, heme means hemoglobin, heme, the blood contain hemoglobin which is red in color. So iron, it is a component. Iron is very important for blood formation. Similarly, a soil which is having high content of iron will give you, or the soil will impart red color. So red soils are mostly have high amount of hematite mineral. In oxidation condition, it gives purple color, the color changes to dark red. Geotite, the formula is Fe2O3 3H2O. When the hematite undergo hydration, you get the mineral geotite. It is brown to dark brown in color. Hematite is red in color, geotite is brown to dark brown in color. Abundant in concretions in certain latosols. In lateritic soils, latosols are important group of order, soil order. Latosols, lateritic soils. So lateritic soils in which the geotite occur as a concretions, as a small concretions in the soil, as ironstone, or in the B horizon, A horizon or B horizon, which more of iron concretions. So this soil is called as the geotite. This mineral is called as the geotite. Then the next mineral, oxide, is over. Then rutile. With rutile, the titanium oxide, the oxide minerals are completed. Then the next one is clay minerals. These are called as the secondary clay minerals. Secondary minerals are those minerals which were subsequently formed from the primary mineral. Primary minerals are quartz, feldspar, silica, pyroxene, amphiboles, etc. Secondary minerals, these are secondary hydrated aluminosilicate of more or less definite chemical composition and possessing certain characteristic properties. So these clay minerals are made up of silica tetrahedra and aluminum octahedral layer. So they are rich in silica and alumina, and the chemical composition is definite. The layered, it is also called as layered silicate minerals. Example is 1:1 type clay mineral, kaolinite. Example is kaolinite. They have a one silica tetrahedral layer, one aluminum octahedral layer. One silica tetrahedral layer and one aluminum octahedral layer. Then this type of clay mineral is called as 1:1 type. Example is kaolinite. Then the next one is called as the 2:1 layer, 2 silica tetrahedral layer and then one alumina layer. 2 silica layer and then one alumina layer. This is called as the 2:1 clay mineral. This is called as the 2:1. The above one is called as the 1:1 clay mineral. This one example is kaolinite and this one example is montmorillonite vermiculite. So these minerals are secondary mineral which can occur in clay fraction of soil besides true clay mineral. These minerals, serpentine, gypsite, pyropylite, chlorite, iron oxide, these are also clay minerals, but they are not regarded as a true clay mineral. True clay minerals are kaolinite, montmorillonite, vermiculite, vermiculite, illite, all these are clay mineral, and the serpentine, pyropylite, chlorite, iron oxide are called as the they are not in the true sense clay mineral, but they are included under clay minerals. The secondary mineral other than clay minerals are hydrated oxides and iron oxide, gypsite, limonite, geotite, etc. These are the other secondary clay minerals. Auxiliary minerals, this group makes a small fraction, usually 1 to 2%. These are important source of trace elements for the plants and animal nutrition. The mineral of this group come under heavy minerals owing to heavy specific gravity, because they have a high specific gravity. When you put it in the bromo form, they will sink inside. So those minerals were called as the heavy minerals, and auxiliary minerals are coming under heavy minerals. They constitute about 1 to 2%, and they are the important trace elements supplying minerals to the plants and animal nutrition. So many of the nutrients are required in small amount. Those nutrients which are required in small amount are called as trace elements. However, these, though it is required in small amount, they are very important for the growth and metabolism of the living organism. Hence, trace elements forms an important component, and the mineral of this group includes heavy minerals owing to high specific gravity. Example is garnet, which contains manganese, and titanite, which contains vanadium, ilmenite, they contains cobalt, nickel, then magnetite, zinc, cobalt, nickel, vanadium, tourmaline, lithium, calcium, fluoride, then zirconium silicate, then andesite, copper, garnet, manganese, etc. So these when you see many micronutrients, you can see here many micronutrients. So when the soil is rich in auxiliary mineral, they supply many of the micronutrients. So these are all very much required for the growth and metabolism of living organism. So with this we conclude the important soil minerals, soil forming minerals. There we saw the definition, the important properties, how they are classified, and what is the importance of this mineral in the point of view of plant growth and animal nutrition. Thank you.